corrosion-prone areas and paint removal. So today's lesson, we're going to cover corrosion-prone areas and paint removal. Should be able to, by the time we finish this lesson, to list the areas in an aircraft that are prone to corrosion. Should understand the characteristics typical to those areas. Describe methods for preventing, limiting, repairing corrosion. Identify safe working conditions, especially when stripping paint. And detail the steps typical to chemical paint removal in corrosion areas. Before we begin corrosion removal, well, first we have to perform an inspection. So our daily inspection, we want to use our daily inspection checklists. Anytime you're on your airplane, you want to be just overall looking, inspecting, looking for areas that are prone to corrosion. You want to be looking for bubbles in the paint. You want to be looking for areas where the paint is chipped or removed. We need to understand that corrosion is expensive. In fact, one of the most expensive aspects in aviation is corrosion control, corrosion removal. We'll never completely eliminate corrosion. Corrosion is always going to be there. The metal surfaces on the airplane are always going to try to get back to their natural or their chemical compounds that they were originally from. So the corrosion is just a never-ending battle that we're going to deal with throughout our life as an aircraft maintenance technician. We don't want to overemphasize the problem, but we need to be aware that corrosion is always there and it's always present. And it's our job to help to control or reduce or eliminate as much as possible the corrosion. Some areas that are really prone to corrosion are the exhaust trail areas. The areas behind the tailpipe, the area that when we're burning fuel, we're creating a hydrocarbon, and when that mixes with the moisture in the air, that actually causes a corrosive surface. You've got high heat from the exhaust, so the high heat is going to blister the paint. It is going to allow these fumes to get up underneath the paint. That's going to cause corrosion up under the painted surface. Areas where the aluminum actually gaps together. If you have two pieces of aluminum that are coming together, the corrosion can get up into that area. Areas that we're not reaching properly and we're not cleaning properly. We need to monitor these exhaust areas. We need to keep them clean, remove any corrosion, and keep a protective coating on any of the bare metals. Rivet heads, skin laps, again, the corrosion can get down in between the rivet head and the skin, or where the joints of the aluminum actually come together. Any of these crevices that will allow these exhaust fumes to get in are going to result in corrosion over time. We want to remove any of the corrosion. We want to keep on inspecting it. Look at the fairings, look at the access panels, pull them off, perform a good inspection. If you can catch the corrosion early, you're going to save time and you're going to save money. The battery compartments are another prone area to corrosion in the battery openings. When you're charging your batteries, you're creating battery fumes. The battery fumes are acidic. Whether you have a NiCad battery or a lead acid battery, you're still producing fumes. There should be something in that battery compartment that is going to catch those fumes and neutralize those fumes. There should be some type of a sump jar. If you have a lead acid battery, it'll have a bicarbonate soda in it or a baking soda impregnated pad. So the fumes are going to go through the pad, neutralize the fumes before they go out to the system. If you have a NiCad battery, you'll have a boric acid. And the boric acid is going to do the same thing. It'll neutralize the fumes of the NiCad battery before we release them to the atmosphere. These fumes, when they're released to the atmosphere or the outside of the airplane, are typically going to go along the belly of the airplane somewhere, and that again is going to be another corrosion-prone area. So keep up with your sump jars, make sure that they're clean, make sure that the pads that are in there are properly serviced with the material, whether it's a boric acid or it's a bicarbonate soda solution. You want to keep them moistened so that these fumes get neutralized before they exit the battery compartment. You want to inspect the compartment good. Any spilled acid is going to cause corrosion. Just the battery sitting in the compartment is going to cause the painted surfaces to wear and expose bare metal. That another area is going to be prone to corrosion. We want to neutralize any acid that's spilled. Again, If you have not, lead acid battery, bicarbonate soda is what we're going to use to neutralize it. So if you know you've spilled some battery, put a little bit of bicarbonate soda on it, rinse it off good. When you're done, when you put the bicarbonate soda on, you should notice it starting to bubble. That's neutralizing the battery acid. Once it stops fuzzing or fizzing, then go ahead and rinse it off good with water. Make sure you get it good and clean and rinsed to reduce any corrosion in that area. The bilge area, or the belly of the aircraft. These aircraft are built, they should have small little bitty holes in the bottom of the airplane. These holes are designed to allow moisture to drain. Any moisture, when I'm talking water, the airplane's going to sit outside in the rain. You're going to get water that's going to drip in from the top and is going to go to the low areas of the airplane. These drains often get plugged. Sometimes they get plugged when we paint it. Sometimes they get plugged with dirt and debris. So you want to make sure that these drain holes are always plugged. If you tow an airplane from one side of the ramp to the other side of the ramp and you change, excuse me, you change the attitude of the airplane, you may notice water leaking out. That's a good indicator. We've probably got a drain hole plugged somewhere. You want to go back under the airplane, start looking for drain holes, maybe get a small piece of safety wire and start cleaning these drain holes out. Any of that water that's left in that airplane is going to cause corrosion. You're going to get water in these bilge areas. You're going to get hydraulic fluid, residual oil, dust, dirt, debris. Everything collects in the bottom of the airplane, and that's going to cause corrosion over time. Another area that's prone to corrosion is the wheel well in the landing gear area. Very vulnerable to corrosion. You get these airplanes when they're taking off and landing in rainstorms are getting pelted with water. The water is getting wedged up into areas that shouldn't have water. This water gets in there and sets in there, and that causes corrosion. Any sand or debris or bugs that are in the air that are getting pelted against this landing gear are going to cause chips in the paint, and it's going to allow moisture to get up under the paint. That's going to cause corrosion. A lot of dissimilar metal. We have magnesium brakes, we have magnesium wheels, we have aluminum brakes, we have hydraulic lines, we have steel, wire, electrical. You've got everything in that wheel well that's all going to contribute to corrosion. And then on top of that, we've got pockets where water can just sit and debris and dirt can sit. And that once that dirt gets wet, it holds the moisture against the aluminum. And again, that's going to cause corrosion. Add to that, you've got the heat from the brakes. Those brakes get extremely hot when it's stopping that airplane. All that kinetic energy from that airplane move-in gets converted into heat energy when that airplane stops. We've probably talked about this already in some of our aviation sciences classes, right? Some of the trouble spots, again, the magnesium wheels. Magnesium is one of the most active metals that we use on aircraft. It is going to turn, or it's going to convert back to its original state faster than any other metal going. Exposed rigid tubing that's going to be up in there. You've got hydraulic tubing that has B-nuts on it that again are going to allow moisture to get up underneath them. That's going to cause corrosion. You've got all your indicator switches. All those switches have electrical wire, which is another electrical path for electrons to flow. That's going to cause corrosion. And then you've just got the crevices that are going to collect water, collect moisture, collect dirt, and it's going to allow that moisture to sit against the airframe and cause corrosion. So again, we'll put that wheel well and the landing gear system up with one of our high corrosion prone areas. Water entrapment areas. We talked about the drains. The bottom of the bilge area of the airplane has drain holes all over it. Again, I can't overemphasize the fact that those drain holes need to be kept clear. They do no good if they're plugged with dirt or debris or old sticky hydraulic fluid. Anything that prevents that water from draining is a bad thing. We want to inspect it daily. You want to look at those holes. You'll pretty soon, over time, you'll start to learn where they're at. You'll get a real good idea what you're looking for. Just keep those drain holes open. Keep them open. Neglected drains get filled with grease, with dirt, with dead bugs. Any of that stuff that gets in those drain holes and limits or slows down the water drain is a bad thing. Engine frontal areas are another high corrosion prone area. This area where the wind is constantly going into the intake, especially on turbine airplanes, high velocity air is going to have dust and dirt and debris in it. This is going to actually work like putting your intake in a sandblaster, and it's just going to take and wear all the paint over time off of it, exposing bare aluminum, and bare aluminum is going to be prone to corrosion. It's going to be a rough surface. The moisture is going to hit it, it's going to attract to it, and then that's going to cause corrosion. Things just taking off, going down the runway, the sand and the debris from taking off the runway, or the exhaust fumes from another airplane blowing on it. All of these things cause the dirt and the debris to blow against that intake and to wear the paint out. A good inspection, look for the cooling path. Look where the cooling air is flowing. Do you notice any paint peeling? Do you notice any bare aluminum? Salt deposits, especially if you're flying out near a coastal area where you're flying in, taking off and landing over salt water, the salt is going to increase the chance of corrosion. So keep an eye on that. Preventative maintenance for corrosion. What can we do to prevent it? Inspect the paint. Look at the paint. Is the paint in good condition? What's going on? Let's keep an eye on the paint. Is it starting to crack? Is it allowing moisture to get underneath it? Is the paint smooth? Are you starting to notice some ripples up underneath the paint? Sometimes if moisture gets underneath the paint during over time, you're going to start to notice the paint bubbling and blistering. Good indicator that we've got something going on under the paint, and it's time that we start removing that paint and looking to see what's going on. Another area that's prone to corrosion is going to be the flap wells or the spoiler wells. These areas, again, when do the flaps come down? Takeoff and landing. Just like the landing gear for takeoff and landing, the flaps are going to be exposed in takeoff and landing. And then, oh, by the way, when the flaps go up, we've got all those areas that are going to entrap water, and unless the flaps are down, you can't see those areas. So during our inspection, we need to make sure we fully extend the flaps, we open up the spoilers, we look down for any area that could have trapped water. Again, the trapped water is going to lead to corrosion. Another thing to think about is our airplanes are not always going to be stored in Miami, Florida. They may be flying up in the northeast or the northwest. In the wintertime, you could get snow up in there. The ice and the debris and the snow gets packed up in these flaps. When the flaps go up and down or the spoilers go up and down, what's that going to create? Again, we're going to be putting ice chunks in there that could be scratching or removing the paint. This stuff is going to get into areas that you just don't want it to be, and over time that's going to lead to more corrosion. The external skin. Pay close attention to the external skin. This is a daily inspection as you're walking by the airplane. Kind of look at it. Notice where the spot welds are at. Notice where the metal actually joins together. Look across the paint. Is it smooth? Do you start to notice a ripple where two pieces of metal overlap one another? Is there corrosion up underneath? All of these little indicators over time are going to show you something that's going on. Piano hinges. Piano hinges, like we see right here in the picture, let's see if I can get ourselves to it, right over here in the picture. If you notice on that piano hinge, you've got an aluminum hinge with a stainless steel pin, and that every time that opens and closes, we have a movement. And no matter what you do to that, you can't keep it painted, you can't keep it greased. Anytime you put any grease or oil or lubricant on there, that's going to attract more dirt. Just watch them. Piano hinges like to corrode. And not only do they like to corrode, but they also like to crack. So now you've got a corrosion problem and a cracking problem with this hinge point, and we have a dissimilar metal. You can just see that there's a lot of inspections that are going to go on these piano hinges. We just really got to pay attention to them, especially if they're forward of an intake somewhere. You don't want something to break loose and get stuck down the engine. That would be a whole nother issue that we'd have to deal with. The spot welded areas, we talked a little bit about it. Spot welding basically what we're doing is we're taking two pieces of metal, we put them between two electrodes. When the electrodes hit, we have current here with a ground here, and when they hit, they shoot electricity through, they superheat the metal, and they actually spot weld it together. Well, when we're spot welding the metal, we're increasing the temperature. That is going to cause some difference in the aluminum alloys. As we get into alloys, we'll talk about alloys, but When we heat treat these alloys, we take them to a specific temperature and rapidly cool them to get all the elements in that alloy where it's supposed to be. Well, you know what? When you spot weld it, you alter that. You add heat to it. You change that chemical mixture, which could turn to galvanic corrosion later on. So watch your spot welds really good. Look at them. Look at them across at eye level and look. If you start to see some ripples, that tells you something's going on down inside that spot weld. Make sure that the spot weld hasn't come loose. If it starts to separate or come loose a little bit and you get moisture up underneath there, just again, focus the spot welds, make sure they're not cracking, make sure they're not corroding, things of that nature. Looking across, sit at the edge of that wingtip and just kind of look towards the fuselage. Notice and see if you've got any ripples. Maybe you want to get a straight edge out and put it on there. Again, notice, you're looking for stuff that doesn't look the same. I'm looking for something just out of the ordinary. What catches my eye? And then focus on that right there. Preventative maintenance for these external skin. What can I do? Well, the first thing I can do is look for these spot welds. Look for any spot where the paint is broken. Look for anywhere that the moisture can get up underneath the paint to cause corrosion. I want to go ahead and fill these spots with some type of a sealant to keep the moisture from getting in before the moisture gets there. If it's exposed and it's been there for a long time and then I seal it, am I putting moisture, am I sealing moisture back inside the aircraft in that sealed area? That would be bad. So again, close attention to detail, catch it before it gets too bad, and fix it before the corrosion starts. Other trouble areas, helicopter rotor heads, any area that has a lot of moving parts exposed to the elements, bare steel surfaces, bare metal surfaces, any bare metal surface, any external part, anything that's working, anything that's caught in the wind stream, dissimilar metal. Dissimilar metal leads to galvanic corrosion. If you put a steel with an aluminum or you put a copper with a steel, any of that dissimilar metal when it gets together is going to cause a galvanic type corrosion. That's stuff we want to kind of keep an eye on. Keep them protected. You should not have a steel bolt in an aluminum structure without some type of sealant around or some type of protective material around that steel bolt, whether it's iodine or something along that line. We want to have something, or the anodized bolt, we want to have something to protect that bolt from the aluminum surface, or you're going to end up with galvanic corrosion. It's going to happen. You can't stop it. Control cables, especially in crop dusters and stuff like that. These control cables are constantly moving. They're actually greased with a para-L ketone. It's a real waxy, greasy substance, and what it does is it keeps the moisture from getting inside the cable. It protects the cable from corrosion. You want to watch these cables really, really close. When you get to the cable, if you look at it, you can actually untwist the cable a little bit, and you can look down inside. Look down inside that cable for corrosion. If you've got corrosion going on the inside of that cable, and oh, by the way, that is a flight control cable, you wouldn't want that to break in flight. So monitor it. If you start to see the corrosion developing, we need to make an assessment. Do we need to replace it, or can it be something that we can inspect it? Okay, inspect it and look at it. When in doubt, replace that cable. You do not want to have a corroded cable left on your airplane that's going to fail over time. While you're inspecting for corrosion on those cables, you should also be looking around the pulleys and stuff like that for wear and tear, for frayed cables and wear in the cable. But again, pay particular close attention. Right now we're talking about corrosion, so that's what we're looking for. Wire brushes. Use caution if you're going to use a wire brush. You don't want to be scarring it up. I would probably steer clear of a wire brush. I know the book talks about a wire brush, but I'd still stay clear of a wire brush. I would probably use like a Scotch-Brite material or something like that to remove the corrosion. And then again, protect it with para-L ketone. That's going to protect it. That's going to keep the surface from getting any more corrosion. And then keep an eye on it once you get it repaired. The complete corrosion treatment. So we want to clean the area, then we want to go ahead and strip the corroded area. I want to clean the area. I want to get all the grease and all that stuff off, because otherwise, if I don't get the area clean of grease when I put my paint stripper on, it's not going to work. So I want to clean my area that I want to strip my paint. I want to make sure that I have no grease or oil or anything like that that's going to impair that corrosion stripper, that paint stripper that I want to put on. I want to make sure that once I'm done with that paint stripper that I properly remove it. I don't want to leave it on the metal too long. I want to neutralize residual materials that are in the pits and the cracks. If I get down in there and I notice I've got some corrosion down, corrosion actually creates what we call a corrosive salt. We want to neutralize that. Your maintenance manual is going to tell you what type of solution to use to actually neutralize all of those salts to keep that corrosion from coming back. And then I want to apply any paints or finishes. Before I apply the paints or finishes, though, I got to do one more thing, and that would be to inspect the material once I've got all my corrosion removed and make sure that I haven't removed too much material. If I've removed too much material in the process of removing the corrosion, there's no need in painting it. I need to go ahead and replace that piece. Surface cleaning. The surface cleaning is going to ensure the compound or the paint stripper efficiency. It's going to help determine the extent of the corrosion. When I clean the surface, now I can start looking to see how bad is the corrosion. Is there something going on other than the corrosion? Is it more than corrosion? Is it just corrosion? Might want to start looking and thinking about what caused the corrosion. Was it the intake area that was just the air blowing across it? Was there an acid somewhere that was leaking? Are we down below the lavatory area where we've got some leakage and stuff there? What's causing that corrosion? Is it dissimilar metal? Is it galvanic corrosion? Is it intergranular corrosion? Several things could be causing the corrosion. Kind of may need to do an inspection, find out where the corrosion, what caused the corrosion. Is it a one-time good deal, or is it something that even when I fix is going to come back? So that's just stuff we need to determine the extent of the corrosion and see if we can't figure out what's causing the corrosion. Again, remember we talked about batteries and battery acids. Is it exhaust fumes? Is it battery acid? What's causing the corrosion? Corrosion and paint removal. What are the standards for where you're at? What can you use? What can you not use? First and most important, we want to make sure that we're following what the EPA says. We don't want to start using something that is going to get us in trouble with the law. Second, we want to make sure we're using something that is not going to do more damage to the airplane. What does the manufacturer say? Is this material you're going to use to remove the paint from the surface, is it going to do more damage to the airplane than the corrosion itself? Third, and one of the things you need to remember, you get a water-based, non-toxic paint remover, but what are you removing? Paint, oil, grease. Is that all toxic? Could be. How are you going to take and get rid of that? Again, this is where you should have some established rules. There should be some regulations you're following. You just don't want to take and remove all this paint and then throw it in a trash can, or you could get a visit that you're really not looking forward to. So follow the EPA rules. When in doubt, ask. Your shop should have some type of policy that says when we do this, this is how we get rid of our hazardous material. Emulsion type solvents are very, very good for removing grease before you get started. You want to get, again, all your grease, you want all your grease and oils off of these surfaces before you start putting these paint removers on the surface. The guidelines. A water rinsable stripper, you want something so that when you're done, you can rinse it off. And oh, by the way, we're going to try to do this outside. We don't want to do it outside at 110 degrees in the sunshine because your paint stripper is going to dry before it has a chance to do its work. So put your paint stripper on, a nice thin coat of paint stripper. Maybe cover it with a plastic to keep that paint stripper from drying. It has to stay moist to work. You may need to apply it 2 or 3 times. Let the paint stripper do its work. Don't rush it. Put it on, let it sit, and wait for the paint to start to blister and buckle. Then go ahead and scrape it off. You want to protect any rubber, any plexiglass, your tires, hydraulic hoses, any synthetic materials, anything that paint stripper is going to damage, you want to protect. Cover it with plastic, tape it off. You don't want to get that paint stripper on. You don't want in the process to removing some paint to fix corrosion and end up damaging a windscreen or something along that line. Mask off any openings or cavities. You don't want to allow that paint stripper to get down in below the surface, because once it's there, you can't get it out. And over time, that's going to cause more corrosion. Remember, paint stripper is toxic. Wear your proper PPE, your protective equipment. You want your rubber gloves. You don't want to get it in your eyes and stuff like that. So let's make sure that we've got our protective gear properly worn. The procedures, again, we talked about paint stripper. We talked about the fact we want to keep a thin surface on it, 32nd to a 16th of an inch thick going across the surface. You need to keep it moist at all times. Do not let that paint stripper cure on the airplane. You want to remove the paint stripper once the paint starts to wrinkle. Don't remove it too soon. Let it sit there, let it work. If you start to remove that paint stripper too soon, you're actually going to create more work for yourself and damage the aircraft. You're going to start scratching the aluminum. You don't want to scratch the aluminum surface. Let the paint stripper do what it's designed to do. Scrub the surfaces with the brush in the paint stripper. So basically what we're going to do is we're going to put the paint stripper on, we're going to let it work, we're going to take our hog bristle brush with some paint stripper on it, and we can put it on the painted surface to try to help bring loosen up that paint. Maybe have some plastic scrapers. Not metal scrapers. You wouldn't want to use a steel scraper on an aluminum paint job, because one, it's going to scratch it. Two, you have dissimilar metal. You have your steel and you have aluminum, and it's going to cause galvanic corrosion. So that would be bad. Maybe you need to reapply it. You've put the paint stripper on. You've got about 80% of the paint off. Maybe you need to reapply it to get those hard to get areas. Get the paint removed off of those. You want to wash any residual stripper off of the aircraft. Again, you don't want to leave it lay there. So we've looked at some corrosion preventive maintenance. We've looked at the ongoing process. We've talked about the fact that as long as you work in aviation, you're going to have to deal with corrosion. Remember, corrosion is one of the most expensive aspects of aviation. Millions of dollars are spent every year on corrosion prevention. Aircraft are going to share many common high corrosion prone areas. The corrosion prone areas are going to be the landing gear, the flap area, the battery vents, the exhaust fumes, the bilge area, the galley. I know we didn't talk much about galley, but think about that. The food in the galley area, when it falls down onto the floor, that's going to hold moisture. Another issue that we have, sodas and pops that are going to be drank or poured and stuff like that. Think about the corrosion that they're going to cause. So look at the corrosion prone areas, know what they are, identify them and inspect them. Each area is going to have its own particular types of corrosion, things you're going to look for, whether it's the battery vents and fumes or it's the moisture from the landing gear in those areas. Know what those areas are. Make sure you're using your emulsion cleaners to remove the grease and the oil. Keep your airplane clean so that oil and grease aren't holding moisture up against the airplane or holding dirt against the airplane. If you keep your area clean and presentable and the paint intact, you're going to reduce the chance of corrosion. You're going to save yourself money and time in the long run.